to another video on the numericals for artificial neural network. The next question that we're going to solve is implement AND function using McCall-Pitt neuron and take binary data as the input. So how do you solve this? It is very simple. Consider the truth table for the AND gate. So this is the truth table where we have two inputs and one output. X1, X2 are my inputs and Y is the output. AND gate is 1 only when both the inputs are 1. So the first line states that x1 is 1 and x2 is also 1, so output is 1. For all the other inputs, your output is going to be 0. So I have to design a neural network which will give me this truth table as the output. So this is the structure or the architecture of the neural network. You have input neuron x1, input neuron x2, and y is the output neuron. Initially, we are assuming both the weights W1 and W2 equal to 1. So this is our assumption. W1 is 1 and W2 is also 1. So next thing that you have to find is the firing of the neuron. When do I want my neuron to fire? I want my neuron Y to fire or Y to be 1 only when both the inputs are 1. So now we'll calculate the net input for our 4 different inputs or 4 different combinations of the input. So for 1, 1, y in is x1 w1 plus x2 w2. We'll put all the values x1, x2, w1 and w2. The first answer gives us value 2. Similarly, we'll solve for all the other combinations and find all the values. So my first condition, when both the inputs are 1, this is when I want my neuron to fire. The output is 2. The net input to the output neuron is 2. So when you get input value 2 to y, only then it should fire, not otherwise, because all the other values are less than 2. So where will I set my threshold theta? Theta, I'll set it equal to or greater than 2. So this is how you design. For AND gate, the output neuron will fire when both the inputs are 1, that is for both x1 1 and x2 1. Y in will be 2, that is what we calculated. So the threshold value theta will be greater than equal to 2. The same thing I can also obtain by the McCall-Pitt neuron equation, which is given by theta greater than equal to NW minus P. N is the number of neurons. We have two number of input neurons. W is the excitatory weight, that is the positive weight, and P is the inhibitory weight, which is a negative weight. So since we do not have any negative weight, the value is going to be 0. So theta comes out greater than equal to 2. How do you write the final equations for the output? Y is the function of the input. As I also discussed last time, the output neuron has two functions. First, it will calculate the summation, and second, we apply the activation function on it. So we calculated the summation y in. Output is a function of y in, and the activation that we're going to work on is when the input to the output neuron is greater than or equal to 2, only then the output neuron will fire, that is, it will give you 1. And if it is less than 2, then the output will be 0. So in these conditions, your neural network will work as an AND gate. So what is my threshold value? Threshold value is nothing but 2. My theta is greater than equal to 2. So this is the end of the numerical. Thank you for watching.